Hey guys, this is the Nerd Herd. I'm Miss Hope Wendell.
I'm Miss Kimberly Emerson.
Mr. Chris Crow at your service.
My name is Katie Hardister.
And today we're teaching you guys about critically. We're going to go over 6 math problems. We're going to start out with an arrangement of circles and the numbers 8, 10, 11, 12, and 13. Kimberly, can you tell us what those numbers mean?
I sure can. The numbers are used to find a sum across and vertically. So if we see an example here, we see that we have 11, 8, and 12 equals 31. And then when we go across, we have 10, 8, and 13 equals 31. So now that we know how to do the problem, where would we start with the numbers?
I think a good place to start using a system of gauge checks. We're going to use a form of deductive reasoning with the information that we do know. And 10 is a good, solid, and even number. So we start with writing 10 in the center. Let's go ahead and look at some problems here. Together with 10 in the center, we can see that it makes a total that is just too large. We're going to have, if we go across there, it would give us the total of 34, so that won't work. So let's try with 10 in the center, again, another total. Well, we can see that it would be 33 if you add up and down, so that's not going to work either. The next logical step that we could use would be to try a lower number in the center. And if you add these together, you can see that those don't necessarily work. But we're going to look at this other circles here. And if we add together 11 and 8, that gives us 19, and 10, that's 29. That doesn't work. But we can look at the problem in the center, and we know that these total 31 up and down. Could you try to give me another method to use to find the answer?
I certainly can, Miss Hope. One of the major methods that you can use in order to find out the numbers and where they need to go in this particular type of question is, more than anything, you can use the simple guess and check method. So guess and check, and we'll use this graph as our next example. The guess and check method is, put plainly, to put specific numbers in spots to try and simply guess the numbers that coincide, the numbers that will add to the, in this case, the box sums. You can simply try and guess and place the correct numbers until all the numbers match up, although it's not the most reliable method because it will take a very long time, and if you're timed, you're going to be in trouble. So the next most logical step would be to try and using heuristics, which is a more sophisticated form of guess and check using a step-by-step pattern or equation, such as seeing that the two numbers on either side of the box numbers are actually the numbers that create the box number. The box number is the sum of the two numbers on each side. 2 plus 5 is 7, 2 plus 8 is 10, 8 plus 3 is 11, and 3 plus 5 is 8. Now, Miss Katie,
Yes.
do the numbers actually matter where they need to be put? Does it actually matter where you put them?
Well, if we take a look here, then we can see that as long as you take one of the numbers, so let's say that we start by taking the number 8, and we put in, let's see here, if we put the number 8 here in the center, and we know here that this is the formula that gives us, if 31 is what we're trying to get vertically and horizontally, does it matter if I put 10 and 13 here, or if I was to put 10 and 13 here? It doesn't really matter as long as that center number is, one of the numbers that we'd use. So a great tool whenever we're doing this is, if we've already used 8, then we can cross it off here off of our list. And we've already used 10 and 13, so now I know that the only numbers left for me to use are 11 and 12. And as long as we have those numbers in the order here, and both the vertical and horizontally, they add up, no, it doesn't matter. So moving on to our next question, I see that we're actually given 9 tiles, and they're laid out on a table in a solid pattern. We want to make sure that each of them touch along a side, an entire edge. Kim, what's the meaning of perimeter?
Unlike area, the meaning of a perimeter is the distance around an object or a figure, so the outside. So I'm going to show us how to find the perimeter right here. So we're going to count each outside of the square tile until we find out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now that I know what a perimeter is, what is the formula for finding a perimeter, Chris?
Well, the formula for finding perimeter is actually quite simple. It's, in the broadest term that I can give you, it is simply adding all of the sides together around a specific figure. So in this case, we have some of these figures with 9 blocks. And if we want to get even a little bit technical, which is often the best idea, we can assign units to these numbers, to these perimeters. So in this case, we see the first figure here is a complete straight line, all 9 blocks in a row, each block having a length of 1 on every side. So in this case, we'll use inches as our measurement of our unit of measurement. So in this case, we'll count each line that is not connected to another cube, that is kind of exposed, if you will. So counting around the figure, we see that the perimeter is 17 inches, which is the main difference between perimeter and area. Now, how exactly do we need to label perimeter, Miss Hope, if you would be so kind as to tell us?
Well, Chris, thank you for asking. Let's see, how do I label the perimeter? We are going to use units of measurement, and we can either use the customary or standard unit length, and that is going to be measurement, which is going to be like your inches, yard, miles, or you can use metric system, which is going to be centimeters, millimeters, meters, and so on. It's very important to label our perimeter, because if we were going to make a fence and it has a perimeter of 18, do we need it to have 18 feet or 18 yards? And if we're going to look at all this, what problem is going to give us the smallest perimeter? Well, we're going to look also the smallest area, or the surface area is going to give us the smallest perimeter. So we're going to look at this set of tiles here, and it's the most condensed, and it's going to have a perimeter of 12. So let me stop screen sharing really quickly. Okay, Katie, is there another way to find a perimeter, and what is the difference between a perimeter and an area?
Well, the difference between an area and perimeter, if you think about, let's say that we're going to be building a fence for our dog. So the area that our dog is going to be playing in is going to be this blue area here, right? So that would be the area, is inside the fence. But if this red here is the fence, that's going to be the perimeter in which our dog is going to be playing within. So it's kind of tricky. So we're going to, if we think about what Chris said earlier, we're going to think that perimeter is going to be each side added together. So we would just add each side, and that would tell us what our perimeter is. And that would tell us the area of our fence. So moving to our next question, Miss Hope, what is a pentagonal number?
Okay, Kimberly, I'm just going to use my board here to explain this because I already have my dots pre-drawn. Can everybody see this clearly?
I can see it.
Absolutely.
We're going to look at these numbers. This is going to be our triangular numbers. And they form a triangle. Now, the funny thing about a pentagonal number is it is 3 times the amount of a triangular number. If you look at a pentagonal number, you can actually split it into 3 parts. So whenever we're actually looking for the formula to find a pentagonal number, we can use sort of similar to the triangular formula, except for this time we're going to look at the formula as n is equal to 3n minus 1 over 2. And if you guys want to try to find a pentagonal number, we can go ahead and try to plug in this. What number do you guys want to try to find? Like the 9th number? You guys want to
Yeah,
try
the
to find
ninth number sounds great.
I like
Okay.
9.
Let's see. We have 1, 2, 3, 4, 5, 6, 7. Okay. Do you guys know what the numbers are? Can you count out the dots here? We have 1 and 5, 12. What is the next one? 21. Does it go 35?
Looks like it.
And is it 51 and 70? Let's go ahead and try to do this 7th number just to make sure, because we already know we have 70 dots here. Let's try to do 3 times 7 and 1. Oh my gosh. I don't think I'm doing this right. I don't think I grabbed the right index card, guys. So it's 21 minus 1 is 20 divided by 2 times 3. Algebra.
So let's take a look. I think I have here, Hope, some dots. Now, don't judge my dots. I am not very good at drawing them here. They kind of went off to the side. But let's see here. So we start with 1 dot.
I know I lost my slides. That's why I had to stop.
So that's okay. We have 1 dot here, and then we do 1 plus 4 equals 5. So we're trying to find, what number was that again? The 9th number?
Yes, we're looking for the 9th number.
Okay. So I see here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I kept drawing the dots, maybe can you see my slide here? It's this one here.
Am I still screen sharing?
No,
Sorry.
no, I don't see. Could you maybe share that formula with me again?
Oh, and now I can see.
What was the formula, Hope?
It was n times 3n.
times 3n minus 1. I actually accidentally grabbed the wrong index card and wrote down the wrong.
Oh, that's
formula,
okay.
But I believe it's n equals n times 3n minus 1 divided by 2.
Okay, so n, I'm sorry, say it one more time for me.
N times 3n
N times 3n
minus 1
minus 1
all over 2.
all over 2. So I see here, so if we were wanting to find the 9th, then all we would need to do is just plug in 9, open parentheses, 3 times 9 minus 1, close parentheses, all over 2. So if you can't do that in your head, that's perfectly okay. You can just grab your calculator and plug exactly what you see in. If you type it in correctly, So I see that it is 234 all over 2. So whenever we say all over, what does that mean? Like divide. So I see that it is 234 divided by 2 equals 117 dots. That would have taken us a really long time to place each of those dots, wouldn't it?
Mhm.
Fortunately
So
so.
it's very important to use the correct formula.
Absolutely. So, Chris, what was the letter N supposed to represent in the pentagonal formula? Pentagonal formula.
Well, the letter N is actually supposed to represent the numbers that you are trying to find.
Okay, so whenever I inserted 9 right here, that represented that we were finding the 9th figure,
Yes.
right? Okay, awesome. And hey, Kim, what was the formula that we used again? I know you shared it with me, but one more time.
It was n times 3 times n minus 1 all over 2, and that is used to find whichever number you are looking for in the sequence.
Okay, so every single time, if I wanted to find maybe like, I don't know, the 100th figure, how many dots would be in there? All I would have to do is just plug in 100 into n, and that would help me find that 100th figure, how many dots would be there?
Yes, ma'am.
That's awesome. Well, moving to
let's
our...
look at a different question.
Yeah. So I think our next one is about the pyramids.
So, Chris, for a pyramid, how would I start solving for a pyramid?
Well, the way to solve an addition pyramid is actually quite simple when you think about it. And if I can exit my screen rather quickly, I will show just how they work. So right here, we can see the basic structure of an addition pyramid. We have our very top layer, we have the second layer, and we have the third layer. So the way that these pyramids are supposed to work is we have our top number, in this case is 25. So then we have our 2 middle layers, which you see are empty blocks. And then we have our third layer, 2 numbers and the x, which we will call a variable. It's supposed to represent a number, but it's not a number that we currently know. So we need to go about solving the pyramid. So in that case, what we can do is create an expression using the variable. So in this case, we have x plus 7. And since we did it for these two, we have to do it for 7 plus 3, which in this case we understand will be 10, and we'll place that there soon enough. So bringing these both down, we can combine the expressions into an equation, which is where the equal sign shows up. So we have x plus 7 plus 10 equals 25. Now in this case, what we're going to do next is we're going to combine our like terms. So in this case, we're going to have x plus 17 and plus 7 equaling 25. What we'll do next is subtract 17 from both sides of the equation, which will give us x equals 8. So now we understand what number our variable is representing. And to use that variable, we can create, instead of x plus 7, it's 8 plus 7, being 15. So then, using 15 as our number, we can therefore finish the pyramid with the 2 blank spaces being 15 and 10, and the x representing 8.
Chris, that was an amazing job explaining that to me.
Thank you. I try to do my best. However, I don't have all the answers. For example, Miss Katie, what do I do when a letter is in place of the number? As I've shown, but that's not the case with every pyramid.
Absolutely. So I see you use the term variable. So is variable what we would call whenever there is a letter in place of a number?
Absolutely.
Okay.
So every letter in math will be called a variable for the
Okay.
term.
All right. So to solve this next one, the variable, all we're going to do is just try to solve for the variable, right?
Correct.
Okay. So, what happens though, Hope, whenever we have less information?
I'm glad you asked, Katie. Let me show you guys something pretty cool. So let's just take this problem for example. Okay, so now we see that we have 1 and have y, and we have 2, and then we have, so these are going to be all the terms that we have. And we know that we're looking for these 2 squares. So we're going to every relative to y. So we know that this square is equal to 1 plus y. This square is equal to y plus. And then all of these together equal 15. So now we're going to combine terms. That's going to give us 2y. We have 1 plus 2 is 3. And then we're just going to go ahead and solve this equation any way that we would normally solve an equation. So it's going to be 2y over 12 divided 2. And that's going to give us y equaling 6. Let's go ahead and try to plug this in and maybe see if this actually worked out. So 1, 6, 7, and 6 plus 2, 8. Did that help figure anything out?
Oh, absolutely.
Okay, but what happens when there is no variable in the pyramid? Kimberly, do you think you could help us answer that?
I sure can. Just give me 1 second. Sorry. Okay, so when there's no variable in the pyramid, obviously it just breaks it down to simpler terms. So see here, whenever we don't have a variable in here, all we do is add 8 plus 9 together, which gives 5. So we'll put 5 here. 3 plus 8 is 5, and 9 plus 4 is 5. 8 plus 9 is 17. And that's all we do when there's not a variable in there.
Awesome.
And then, Hope, how do I organize the words in a problem to find an answer on a new equation?
Okay, so we're going to be working with the word problem.
Yes.
I think this is the one that has about husbands and wives, and they're playing bridge. Okay, let's go ahead and just organize all the words we have in the problem. We know that there is a bridge team, and that they are the wives. We have Anne, Kitty, Josie, Sarah, and then the husbands in no respective order are going to be Will, Dave. Wait. The clues we have are in the word that Floyd is Josie's brother, Josie and Gus dated son, and you can read all that for yourself to organize this to try to help figure this problem out. So we're going to create a chart. We're going to add the wives at the top. Their names are Kitty, Joe, and the husband's names are Will, Floyd, Gus, and David. Okay, and this is going to be our first step into solve. But what do I do if the clue helping me to solve the graph? Chris?
That's actually a very good question, Hope, and I'll be more than happy to explain it. It's actually a very simple explanation as to what you do if you're dealing with a clue that isn't actually helping you all that much. So the way these clues work is that obviously they're clues, so they're supposed to help you understand how to complete these problems. Mm-hmm. So as soon as my screen finishes loading, we can see here we have about 5 different clues. Most of them seem to be pretty helpful, indicating who is married to who isn't married, who dated but is not currently together. And then we have an odd clue, the second to last one. Anne has 2 brothers. Now, in the context of the graph here,
Is this what it is? An expense? I'm sorry to interrupt you, Chris.
No, you're fine. So what you do if a clue isn't helping you is you have to analyze it for a second, understand that it doesn't have much prevalence over the actual question. Well, that's what I would like to call a false clue. It's trying to mislead you by giving you information that is not exactly pertinent to the question. The fact that Anne has two brothers isn't necessary to figure out who Anne is married to. All it tells us is that she has two brothers, neither of which are any of these men right here. So the clue is kind of inconsequential. It's unnecessary. It's false.
But hey, Chris, could these clues be used in the
However-
process of elimination?
Absolutely. The
Just by
process of
marking dots?
elimination is incredibly simple so people understand what you're doing. So using the clues, we can pinpoint who is married to who. So starting off with the first clue, for example, we see that Floyd is Josie's brother. So that immediately eliminates Floyd and Josie from being married at all. And moving on to the second clue, we can see that Josie and Gus dated some, but then Gus met his present wife. So that eliminates Gus and Josie from being married as well. The third clue indicates Kitty is married to Will, which is not only a clue, it's a given answer to help us cut this entire process in half. So since Kitty and Will are married, that immediately cuts off Kitty from being married to any of the other men and Will from being married to any of the other women. And again, using the process of elimination, we understand that since Josie cannot be married to Will, Floyd, or Gus, she has to be married to David. And then going through the rest of this process, slowly eliminating the rest of the people and who they're married to, we can find out who they're not married to, and then find out who they are married to as the final answer.
So, Kim, is that how we would use the process of elimination to solve the problem?
That sure is. You find out which answers you know first, mark them off, and then keep going until you have no more answers.
Okay. So, did we decide then who was married to who?
Yes, we did. As Chris showed us in his video. So let's look at another problem. Let's look at problem 6.
Okay.
So I'm not very good with dots, so I was going to ask Hope if she had another way I could arrange the dots into a better sequence, which is better for me.
Are we thinking of the trapezoidal numbers in this problem?
We sure are.
Okay, I think so. I think I may have a way to arrange these dots. Let's see. First, we can see that the dots originally arranged form a trapezoid. But I would like to implore that it would be easier to manage the dots if we arrange them in columns and rows. This way, we can use multiplication instead of adding each dot in each row as it goes. We can use a form of multiplication. And we can see it's much easier when they are arranged in columns and rows than when
Well, looking at those trapezoidal numbers, Katie, is there a pattern that we're following?
You know, it does actually look like there is a pattern that we're following. Let me share my screen and maybe I can point out. So it looks here like whenever, like Hope was saying, we take these numbers here and when we rearrange them into these rectangles, it definitely makes it much easier to view. And it looks like we have 1 plus 1 plus 1 equals 3. And then 1 plus 2 plus 2 plus 2 plus 1 equals 8. So I would say that there's definitely an easier way to maybe express that which is saying 1 times 3 equals 3. Because isn't that the same thing as saying 1 plus 1 plus 1?
It sure is.
Absolutely.
I think that that's kind of, whenever Hope shared with us rearranging them, it's definitely an easier way instead of saying 1 plus 2 plus 3 plus 4 plus 4 plus 4 plus 4 plus 3 plus 2 plus 1 equals 24. It's much easier once, we rearrange the dots that we can absolutely just say 1, 2, 3, 4, 4
Mhm.
times 1, 2, 3, 4, 5, 6. 4 times 6 equals 24. So, hey, Chris, this problem looks somewhat familiar. Could you maybe tell me how this problem might relate to another problem that we've seen before?
Of course. And you would not be wrong in saying that this question pertains to other ones that we've seen because, like previously, we have trapezoidal numbers, but we also had rectangular numbers and triangular numbers and the pentagonal numbers.
Mm-hmm.
And the way it relates is it's simply a matter of placing dots as well as understanding patterns.
Okay.
So in the original pattern, we not only have to solve what the formulas are for these numbers, but we also have to apply that formula to the dots as well as the numbers in order to find the nth term, the 100th term number, and so on and so forth.
Mm-hmm. Hope, what was that you said? I'm sorry.
Oh, I call it. I didn't realize that Chris was still talking. I was wondering, is this a form of arithmetic, like our dot patterns, and when we're using to find our triangular, square, and pentagonal numbers? Are we using arithmetic sequence or the order of the numbers? Like the constant difference, higher or lower, say like
Mhm.
adding 3 to the number previous.
And we sure are using that.
Yeah, I think so too. So, did you guys learn a lot about critical thinking in this class? I know I did.
I definitely would say
I
I've
would
used
definitely
some.
say I'm more knowledgeable on the subject.
I think that we definitely found some useful tools.
Okay, great. So maybe we can take this forward in the future and really apply ourselves mathematically and our math muscles strong. Thanks from the Nerd Herd, guys.
Thank you,
Later.
guys.
See ya.
Thank you for listening to us.